So I had a request for a piecewise function. We are not graphing piecewise functions. We're not graphing piecewise functions at all. We are evaluating piecewise functions. So for this particular piecewise function, we are evaluating f of negative 2. And so what that means is that we have to come up here and we have to look at which one of these piecewise functions that we're going to do. And we look at where it says x is less than negative 1 and x is greater than or equal to negative 1. So because what we are plugging in for x, I am plugging in a negative 2 for x. So I am going to use this function right here, this one, because the value that I'm plugging in for x is less than negative 1. So that's how I do that. So I'm picking the top one for this particular function. So what I'm going to do then, so I'm going to say negative 4 times negative 2 minus 4. Negative 2 times negative 4 is positive 8. And 8 minus 4 is 4. Okay? And I used negative 4x minus 4 because of this rule right here. That's why I used that. Now for our next one, I have f of negative 1. Okay? And negative 1 is where things change. Negative 1 is where things change. But do you see how this one says or equal to? So because that one's greater than or equal to, it's because of that or equal to mark that I use that rule for negative 1. Now, one of the mistakes that students make very often when we are squaring a negative is they forget to put that negative 1 inside parentheses. What is negative 1 squared? Positive 1. Good, okay? And a lot of people will write it like this. They'll write negative 1 squared. And if they put that in their calculator, that just comes back as negative 1. So it's better if you go ahead and write it like this, the negative 1 being squared. Hey. Okay? So then we have 2 times negative 1 is negative 2. Okay, our 1 and our negative 1 cancel. So my final answer to this is negative 2. Okay, and my third one that I'm going to figure out is f of positive 1. We are going to use this one again because positive 1 is greater than negative 1. So we're going to use that second function again. So I'm going to have 1 squared plus 2 times 1 minus 1. 1 squared is 1. 2 times 1 is 2. Again, our 1's cancel each other out, and I'm just left with a 2. Now, piecewise function, what you have to really focus on when you're doing a piecewise function is when to use which function. That right there tells you which function to use based on the number that's right here. You pick which function to use based on what number you're plugging in. Okay? And pay special attention to where that or equal to sign is. Pay special attention to the line. So this one is the greater than or equal to. Because I can guarantee you are always going to have whatever that number is. Like here it was negative 1. You're always going to have that number. And you're going to have to decide which function to use. And so you look for the one with the or equal to. Okay? Okay. Any questions about piecewise functions? And we are not graphing piecewise functions just yet. We'll graph them towards the end. Okay, now the next one that I'm going to do is like one that was on your quiz where we had domain and range and increasing and decreasing. Number 26. Okay. So this one is, we're going to find a little bit of everything. So if you will give me just a second, and I will draw this out as best as I can. Okay, so that's going to be our y-axis. And our x-axis is going to be kind of down here. And actually, now that I think about it, I have a lot of people in my office about this one. Okay. So, I'm going to start right here. Our maximum is going to go all the way up here. We're going to hit right here. Okay, and then we're going to finish right here. Okay, so this is what my graph looks like. Okay, and because this point right here is 5,9, and I want you to go ahead and think about what that point is right there. Just because we're so far away from the x-axis, you can't see exactly where that tick mark is. So that point right there is 5,9. Okay, this point right here, this one at my very top, what point is that right there? What's my x value on that one? 0. Good. Good. And we can count 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So that's that point right there. 0, 9 is a relative maximum. A relative maximum because it changes directions. We hit it and it changes directions. Okay? What is this point where I hit the x-axis? What point is that? 3, 0. Good. 3, 0. And this point on the left, what point is that? Good, -4, 1. Now, if you write out these particular points on here, sometimes it's easier to say, oh, I've only got to focus on the x. Or, oh, I'm doing range, I only focus on the 9, or the y. So if you identify kind of those key points and you put that ordered pair there, that keeps you a little bit more focused on only the x's or only the only the y's. So we're going to start with domain. We're going to start with domain, and then we're going to go to range. Okay? Now, domain is only our x values. Only our x values. So the point that I have furthest to the left is this point right here. What is my x value in that point? -4. Good, good. And the furthest point that I go to on the right is all the way over here. What is the x value in that point? 5. So we go all the way over because we're really looking at this point right here is what we're looking at. Okay? Now this is a little bit easier than what we had on the quiz because it's continuous. It goes all the way across. So my domain for this one right here is -4, but I need a bracket, and I need a bracket because that dot is colored in. That's why I have to have a bracket there. And then I'm going to the 5, and I need a parentheses there. So this is my domain right here. And notice that I focused on my x values for each of those ordered pairs. Okay? Okay. Now we're going to focus on our y values because we are doing range. This point right here is my lowest point, okay? These 2 points right here are my highest point, and we're talking about range, so we are only looking at the y value, okay? So this is my y values, okay? Where do I start with my y values? 0, and how high do I go? 9. Excellent job. Okay, so I start at 0 and I go to 9. Now, this point is open, but this point is closed. So is 9 included in that? Yes. Why? Good, because one of them's closed. If they were both open, then 9 wouldn't be included, but one of them's closed, so you've got to include it. Okay, so that's your domain and range. This point right here, this 3, 0 right here, that is where I am touching the x-intercept. That is my x-intercept, and that's the only x-intercept that I have. I only have one of those. Okay, so x-intercept is 3, 0. Okay, now we're going to do increasing, decreasing, and constant. Okay, now we are back to only focusing on the x value. We're only focusing on the x value for increasing, decreasing, and constant. So, what is happening right here and right here? What's happening? Increasing. Okay, so what are my y values for those? I'm sorry, I said y values. I'm very sorry. I'm very, very sorry. For some reason, I am exhausted this afternoon. I only want my x values. I apologize. X values. What are my x values for increasing? -4 to what? 0. Good. Good, good, good. -4 to 0. And that covers this one right here. Okay? Now, what's the other one? So we said -4 to 0. Okay? So what's this one right here? 3 to 5. Good, because we are only focusing on the y values. X values. Oh my goodness. Oh my goodness. We're only focusing on the x values. So actually writing that ordered pair out is super helpful because then you're like, okay, that's my x value. That's my x value. That's what I'm focusing on. Okay, and so we said 3 to 5. And that's a union right there. I know that's a little hard to see. And then I have 3 to 5. Typically, increasing, decreasing, and constant, you always use parentheses. Yes, ma'am?
Okay, I was about to ask, why wouldn't it be brackets?
And if you put brackets on your test, I'm going to give you full credit.
Okay.
Yeah. Just in general, when we're doing those intervals, it's parentheses.
Okay.
Yeah, but I would give you full credit for brackets. Okay? We only have one interval where we're decreasing. And we're still focusing on those x values, and we are decreasing right here. So tell me the x values where we're decreasing. 0 to, perfect. Okay, do we have anywhere that's constant? No. So on your test, you can write none. I think on your homework, it asks you to put does not exist, or DNE. Okay. It would be a straight line, like it would be a horizontal line. That's a great question. It would look just like this. That's always.
Okay.
If something's constant, it's always going to be horizontal because it has a slope of 0 and there's no change. Good question. So I'll put right here, this is what a constant would look like. And if you remember, That's going to be a slope of 0. That's,
So that's what you would draw for the cost of just.
yes. And it's where, if we think about the stock market, it's where you make no money. You don't make money, but you don't lose money. You don't lose weight, but you don't gain weight. You're staying the same. Okay? This point right here, 3, 0, is that a maximum or a minimum? Is that a relative maximum or a relative minimum? Minimum, because it's low. Okay? So this is your minimum. Okay? And your maximum and your minimums change direction. Okay? So what's this right here? Maximum. Okay. Now, just for fun, as you giggle, just for fun, if this kept going like that, and this kept going like that, okay, how would I write my increasing? What would my increasing intervals be? Excellent. Excellent. Negative infinity to 0. That's going to be my increasing. Okay. And where else is it increasing? Good. And we started at 3 right here. So it would be 3 to positive infinity. Good. Excellent job there. Good. That wasn't terrible. It does give us a little bit of fits, though. Okay. Okay.
If there was a problem on the test, how many points would this be worth? Like, just like this?
There is one on the test. I don't remember.
Okay.
But I can tell you exactly after the study session.
Okay.
So, the top of my head, I'm thinking 5, but I just can't say that definitively. Okay, so let's move into 1.6 through 1.9. We've got several different ones we want to do from there. I am going to start on number 30, and I think it's a fog and a Goff, but I'm not sure. Yes. Yes, it is. This is a little bit, so this is composition of functions. This is composition of functions, and it's one of the more challenging composition of functions because you're dealing with a rational or a fraction. Okay, so this one is a little bit more challenging. So what I am being asked to do is I am being asked to find f composed of g of x. F of x is 8 over x squared minus 1. And g of x is x plus 1. I knew that was going to happen. Okay, there we go. So our first one is f composed of g. F composed of g. So you're always going to take the second one and plug it into the first one. Okay? We are going to plug g in for x in f of x. Okay? So whatever your second one is, you're going to plug that in to the first one. So I'm going to take x plus 1, and I'm going to put it for this x right here. That's what I'm going to do. Taking x plus 1, and I'm putting it in for that x. Now, you may be a little worried because we're in the denominator, but don't be. Don't be worried about that one. So this is going to be 8 over I'm going to put x plus 1 in for that x, and then I'm going to square it. Okay? So all I did, I took this x right there, and I plugged that in for it. That's what I did. Now we're going to simplify. So I'm going to simplify my x plus 1 squared. This is x plus 1 times x plus 1. And I had a few questions about that. Don't forget, the x plus 1 squared means you've got to FOIL it. So I've got x times x is x squared. X times 1 is 1x. 1 times x is 1x. And 1 times 1 is 1. Okay? So now I have 8 over x squared plus 2x plus 1 minus 1. My plus 1 and minus 1 cancel out. So my final answer to this is 8 over x squared plus 2x. That's my final answer for that one. Okay. Can I erase this? Okay. Now, G composed of F is a little bit more challenging because we're going to have to do something a little funky with the rationals. So now we are going to do G composed of F of X. So we are going the other direction. I am taking F and I am plugging that into the G. So this time I am going to take 8 over x squared minus 1, and I am going to plug it in for that x right there. That's what we're doing for that one. So I have 8 over x squared minus 1, and I am adding that to 1. Okay, now if you remember back to chapter 4 in 131, okay, yeah, I'm seeing, okay, we are going to add this rational. We're going to add these together. So I've got to get a common denominator. I've got to get a common denominator. So I am going to do 8 over x plus 1 times x plus 1. Okay. Okay. Then I've just got 1 over 1. So what am I missing in the 1 over 1? What do I not have in my denominator? I don't have, oh, one of these is minus. This is x plus 1, x minus 1. Okay, so I have to put both of these in this denominator right here. Okay, if I've got it in the bottom, what do I have to do to the top? Same thing. Okay, that's how I get my common denominator. Okay, and none of these are going to cancel out. So I can leave this, I can go back to x squared minus 1 because I'm not going to be able to cancel anything out. So my new denominator is x squared minus 1. So all I've done is made one fraction and then multiplied my FOIL back out. Okay? So then I've got 8. Now this right here, x plus 1, x minus 1, what does that become? I'm just FOILing it. X squared minus 1. Then I've got 1. 1 times x squared is just x squared. 1 times negative 1 is just negative 1. Okay? Now, can I simplify that at all? Can my top be simplified? What is 8 plus negative 1? 7. Okay? So then I have x squared plus 7 over x squared minus 1. Okay? Now we're going to piggyback off of this slightly and talk about domain. We're going to talk about domain because this is a great example of when you have to limit your domain. Okay? Can I erase this part of it? Okay. So what I want to do now is I want to focus on f and g of x, and I want to talk about the domain of both of those. Okay? So f of x, I've got x over x squared minus 1. And then g of x, I have x plus 1. Now, if I look at the domain of g of x, what could I put in for x? What can my x values be for g of x? Is there a fraction in g of x? No. Is there a square root in g of x? So what can I plug in for g of x? Anything. How do I write anything? Negative infinity to? You got it. Good job. Perfect. Okay? Now, for this one, for x squared minus 1, x squared minus 1 cannot be 0. Okay? So I'm going to factor it, and you typically do very well when you factor. So you've got x minus 1, or x plus 1 times x minus 1 cannot be 0. Okay? So then I set each one of these to 0. Okay, so I have x cannot be negative 1 and x cannot be 1. Okay, now we are going to look at a number line so that we can make sure we get this correct. Okay. X cannot be negative 1. So I'm going to put a circle there because my answer cannot be negative 1. I can't have positive 1 either. So I'm putting a circle there. X can be anything except where those two circles are. Okay? So X can be all of this, and X can be all of this. The thing that students forget is it can also be any of this. Okay? So now I'm going to write that in interval notation. And that starts at negative infinity. And I am moving from left to right. So after negative infinity, what's the next number that I come to? Excellent. Okay, and I keep going. Okay, so I have started at negative 1, and I've gone to what? Good. Okay, and then I've got one more interval. Perfect. Perfect. There we go.
So you only have to do that when it's like a square root or like something really small.
The only time that you have to limit your domain is when you have the square root. So when you've got an x inside the square root, or you've got an x in the denominator of a fraction. These are the only two times that you have to limit your domain. And just to make things slightly more confusing, okay, what is the difference between this right here and this right here? What's the difference between those two? Correct, okay? So the square root of x is a square root. And when I've got square roots, I can only have positives in there. The blue, that is a cubed root. In cubed roots, negatives are okay. So I'm going to write cubed root, and that's what makes it a cubed root right there, that 3. Cubed root negatives, okay. Oh. Okay. Oh, I definitely want to do 41. Definitely. Okay. Can I move off this screen? Okay. So 41 is an inverse function. It wants us to find the inverse function. So I have f of x equals x to the third plus 2. That's my original function. Okay? So the first thing that I'm going to do is I'm going to replace f of x with y. Okay? That's the first thing I'm going to do. So I'm going to take out f of x and I'm going to put y. So I have y equals x to the third plus 2. Okay? The second thing I'm going to do is switch x and y. Okay? So I'm going to switch both up. I'm going to switch the x and the y. So that means that I'm going to have x equals y to the third plus 2. Okay? Anybody know my next step? What do I solve for? Excellent. So we are going to solve for y. Okay? And the way that I do that is I subtract 2 from both sides. So I have x minus 2 equals y to the third. Okay? What do I do for y to the third? How do I get rid of the third? What do I take of both sides? Excellent, the cubed root. That's exactly what I do. So now I've got the cubed root. So I'm taking the cubed root of both sides. So I have the cubed root of x minus 2 equals y. Is it okay for me to have negatives inside a cubed root? Yes, it is. It's completely fine. Now my fourth step then is to replace y with f inverse of x. Okay, so my final answer to this would be f inverse of x equals the square root, or not the square root, I apologize, the cubed root of x minus 2. Okay, now this is my original right here. This is my original function right here. My original function. What's the domain of my original function? X to the third plus 2. What's the domain? Do I have to limit that domain at all because I've got a square root or I've got a variable in the denominator? No. So what's my domain? Excellent. Negative infinity to positive infinity. Okay, I don't know what my range is yet, so we're going to hang tight with that one. This one is my inverse. Now be careful. I've got a cubed root right here. Is that a square root? No. So what's my domain for my inverse? What's the domain? It's the same thing, negative infinity to positive infinity. Okay? Now, the domain of my original function is the range of my inverse. The domain of my inverse is the range of my original. Okay? Do you remember how I told you that there was a more challenging inverse and then there was a less challenging inverse? and that the less challenging was going to be on your test and the more challenging was going to be on your project? Okay. This is what I consider less challenging. Okay, so you need to, I would pay special attention to this particular problem right here. Okay? Okay. Okay. The last one that I'm going to do is a difference quotient. Does that sound good? Difference quotient. Okay. Is that okay? Can I move off the screen? Anybody got what they need? Okay. Okay, this is a difference quotient. I have x squared minus 2x plus 4. Okay. And I want to find the difference quotient. So that's f of x. No, I'm sorry. It's f of x plus h minus f of x all over h. So the first thing that we are going to do, is we're going to find f of x plus h. And that's what I'm going to do in red. Find f of x plus h. So what that means is I've got to plug x plus h into here and to here. Now, I looked at a couple problems today, and almost everybody remembered to plug f of x into here, or x plus h into here, but they forgot about that x right there. So be sure you plug x plus h into both of them. So let's see what this looks like. I have x plus h squared minus 2 times x plus h plus 4. Okay? That is my first step. My second step is to subtract f of x. So you've got to remember to distribute here. We forget to distribute right here, so be careful. So I am going to subtract all of my original. So I have x squared minus 2x plus 4. Okay. Now, my third step is to divide everything by h. Okay? And now I'm going to simplify, but I'm going to keep some of my colors going, okay? So, the first thing that I've got to do is I've got to do x plus h squared, okay? And x plus h squared means x plus h times x plus h. X plus h times x plus h. So we have to FOIL that. X times x is x squared. X times h is xh. H times x is hx. H times h is h squared. Okay? So this is x squared plus 2xh plus h squared. Okay? Now all I've done, though, don't get too excited because I haven't done all of the red. The only part of the red that I've done is this right here. That's the only part of the red that I've done. I still need to do the minus 2 times x plus h and the plus 4. So I'm going to distribute my negative 2 now. So I have negative 2x minus 2h plus 4. Okay? All of that is still my red. Now I'm going to distribute my negative sign. So I have negative x squared plus 2x minus 4. Okay, so I distributed my negative sign for the subtract. Now I'm going to start canceling. Whatever can be canceled, I'm going to start canceling. Okay? So I have x squared and negative x squared. I've got negative 2x and positive 2x. I have plus 4 and I have negative 4. So pretty much everything that does not have an h, you are going to cancel out. So I'm left with 2xh plus h squared minus 2h over h. Okay? So now I'm going to take an h out. So I have 2x plus h minus 2. Okay? And my h cancels. So my difference quotient here, my final answer for the difference quotient is 2x plus h minus 2. Okay? So that is a difference quotient right there. And I think that's probably a good overview of some of the more difficult problems. Focus on practice test, classwork today, and quiz. That's going to be your best bang for your money. Okay?